June 6, 1944, 03:54 hours, Normandy, France. Lieutenant Colonel Mike Murphy pulls back on the control column as the nylon tow rope releases with a sharp crack. The C-47 ahead banks away into the darkness. Silence. Not peaceful silence, the terrible roaring silence of wind tearing past canvas and wood at 72 miles per hour as his Waco CG-4A glider, designated Fighting Falcon, begins its descent toward occupied France. Murphy's hands are steady despite what sits directly behind him. Brigadier General Donald F. Pratt, Assistant Division Commander of the 101st Airborne Division, strapped into the passenger seat of his own Jeep, which is strapped to the glider's plywood floor. The floor beneath the vehicle consists of 5,000 interlocked wooden pieces, a honeycomb design meant to distribute 4,000 pounds of weight. Tonight, it holds more than that. The nose of the glider, armored with steel plates added specifically to protect the general, has pushed the aircraft's weight past its design limits. Through the plexiglass nose, Murphy can see other gliders descending through the pre-dawn darkness. Tracer fire arcs upward from German positions. A glider to his left takes a direct hit, its canvas skin erupting in flames as it cartwheels toward Earth. The landing zone, a field near Heesville, rushes up. Murphy flares the wings, bleeding speed. The glider's wheels touch grass. Then everything goes wrong. The extra armor weight drives the glider forward across the wet Norman field without slowing. The hedge line ahead solidifies from shadow into unmistakable reality. Impact. The tubular steel frame collapses. The Jeep tears free from its moorings. Murphy feels his legs snap. The co-pilot beside him dies instantly. Behind him, Brigadier General Donald F. Pratt's net breaks as the Jeep crushes forward into the cockpit. In the field around them, 51 other gliders are landing. Some touch down perfectly, others slam into hedgerows, into each other, into the trees that line every Norman field. By dawn, when American infantrymen reach Landing Zone E, they will count the cost. 5 dead, including 1 general, 17 wounded, 7 missing. This is the price of silence, the cost of landing entire squads with their equipment exactly where they're needed, delivered not by roaring bombers or vulnerable parachutes, but by engineless aircraft made from materials found in a furniture workshop. If you're moved by these true stories of courage and sacrifice and want to understand the hidden ingenuity behind them, support us with a like. It truly helps us continue sharing these crucial moments from history. Subscribe if you haven't already. Now, to understand how America came to build 13,903 of these disposable wooden gliders and why companies that made pianos and refrigerators ended up providing the components, begins 3 years earlier, when the U.S. military faced an impossible problem: how to land an army silently behind enemy lines without the industrial capacity to build it from metal. The problem emerged in May 1940 when German glider-borne troops accomplished what military experts had declared impossible. May 10, 1940, Fort Eben-Emael, Belgium. The fortress dominated a strategic position along the Albert Canal, 70 acres of reinforced concrete, steel cupolas, and underground galleries housing 1,200 Belgian soldiers and the most modern artillery in Europe. Military planners considered it impregnable. The Germans took it with 85 men in 24 hours. 42 DFS-230 gliders, each carrying 9 assault engineers, landed silently atop the fortress at dawn. The Belgian defenders never heard them coming. By the time they realized German troops were literally standing on their roof, shaped charges had already begun blasting through the fortress's armored cupolas. Within a day, Eben-Emael surrendered. The route into Belgium lay open. The audacity stunned Allied military observers. Traditional doctrine held that fortifications could only be reduced by lengthy siege or overwhelming force. Germany had just demonstrated that gliders could deliver small, highly trained units with surgical precision and do it silently without the drone of engines to provide warning. The lesson became unmistakable 1 year later during Operation Mercury, the German invasion of Crete in May 1941. Despite catastrophic losses among German paratroopers, glider forces had delivered intact combat teams with their heavy weapons directly onto key objectives. The DFS-230 gliders carried 75mm guns, combat engineers, and specialized assault troops to captured airfields that parachute forces alone could never have secured quickly enough. U.S. Army observers took careful notes. General Henry Hap Arnold, commanding general of the U.S. Army Air Forces, recognized that America would eventually need its own glider force. Paratroopers could seize objectives, but they landed scattered and carried only what they could jump with. Gliders could deliver complete squads with jeeps, artillery pieces, and ammunition, everything needed to hold an objective once taken. In early 1941, Arnold initiated what would become the most chaotic aircraft procurement program of the war. The U.S. military needed thousands of gliders. It needed them quickly, and it faced an immediate problem. Every aircraft manufacturer in America was already working at maximum capacity building bombers, fighters, and transports. Ford couldn't build gliders. Ford was building B-24 Liberators. Boeing couldn't build gliders. Boeing was building B-17 Flying Fortresses. Douglas, Lockheed, Consolidated, all the major aircraft companies had their production lines committed. The solution would require thinking far outside traditional aerospace manufacturing. The Waco Aircraft Company of Troy, Ohio submitted the winning design in May 1942. Chief designer A. Francis Arcier, a London-born aeronautical engineer who had designed bombers for the Allies in World War I, created a brilliantly simple aircraft that prioritized ease of manufacture over sophistication. The CG-4A, C for cargo, G for glider, featured a high-wing monoplane configuration with a hinged nose section that swung upward to create a 5-foot by 6-foot cargo opening. The specifications were straightforward: wingspan of 83 feet 8 inches, length of 48 feet 4 inches, capable of carrying 13 fully equipped troops or 3,750 pounds of cargo. But the revolutionary aspect was its construction. RCA designed the CG-4A to be built using woodworking techniques rather than aircraft manufacturing processes. The fuselage consisted of welded steel tubing, the kind furniture makers used. The wings were built from laminated wood using techniques borrowed from boat construction. The entire aircraft was covered not in expensive aluminum, but in cotton canvas doped with cellulose acetate to make it taut and weatherproof. The floor was a marvel of carpentry, over 5,000 interlocking wooden pieces forming a honeycomb structure capable of supporting a fully loaded jeep. This design made the impossible suddenly feasible. If gliders required woodworking rather than metalworking, America's vast furniture industry could build them. Companies with expertise in laminating wood, stitching fabric, and welding tubular steel could become glider manufacturers. In June 1942, the Army awarded contracts to 16 primary manufacturers. Ford Motor Company converted its Kingsford, Michigan plant, which had built Woody station wagons, to glider production. The Gibson Refrigerator Company of Greenville, Michigan, received a contract for 1,078 units. Northwestern Aeronautical Corporation of St. Paul would build 1,509 gliders. Cessna Aircraft got a contract for 750 units. But the most remarkable contracts went to subcontractors producing component parts. Steinway Sons, the legendary piano manufacturer, converted its Queens factory to produce wings and tail surfaces for the gliders, using the same laminated wood techniques it employed for soundboards. H.J. Heinz Company in Pittsburgh, better known for ketchup and pickles, manufactured wings and spar tips. Anheuser-Busch Brewing Company in St. Louis produced inboard wing panels and wooden fuselage frames. Even Gardner Metal Products, a St. Louis coffin maker, received contracts to produce steel fittings. By late 1942, America's glider program had mobilized an industrial base unlike anything in aviation history. Piano makers, furniture builders, and beer brewers were now critical suppliers to the Army Air Forces. The first combat test came in July 1943. July 9, 1943, 450 miles off the coast of Sicily. Operation Ladbroke, the glider component of the Allied invasion of Sicily, launched from Tunisia as night fell. 144 gliders, a mix of American Waco CG-4As and British Horsa gliders, took off towed by C-47 transport aircraft and Armstrong Whitworth Albemarle bombers. Their objective: seize the Ponte Grande Bridge south of Syracuse before it could be demolished by Italian defenders. The mission represented the first large-scale American glider operation of the war. British pilots who had never flown Waco gliders before receiving them in North Africa had only 3 weeks of rushed training. American towplane pilots had minimal experience with night formation flying. Weather forecasters predicted clear conditions. They were catastrophically wrong. As the Armada crossed the Mediterranean, winds reached gale force. Heavy clouds obscured navigation landmarks. American C-47 pilots, many flying in combat for the first time and struggling with turbulence, released their gliders early, some as far as 6 miles offshore. British pilot Lieutenant Dennis Galpin, released 6 miles from shore, somehow managed to glide his Waco to the Ponte Grande Bridge, the only pilot to land on target. 86 other gliders never reached Sicily at all. They crashed into the Mediterranean. Some pilots fought to keep the nose up as the aircraft slammed into 10-foot waves. Others ditched successfully, only to watch as their gliders, built from wood and canvas, broke apart in the surf. Men clawed their way out of sinking gliders weighted down with equipment. Some drowned, trapped in harnesses. Others made it to the surface only to be swept away in the darkness. By dawn, more than 250 British glider troops were dead, drowned in the waters off Sicily. Of the 58 gliders that reached land, only 12 landed near their assigned objectives. The others came down scattered across southeastern Sicily, some 25 miles from their targets. Despite this chaos, 87 British airborne troops from scattered gliders managed to assault and briefly hold the Ponte Grande Bridge until Italian counterattacks overwhelmed them in the afternoon of July 10. The disaster generated immediate controversy. Eisenhower seriously considered abandoning large-scale glider operations entirely. The Sicily experience suggested that gliders might be inherently unsuitable for combat, too dependent on perfect weather, perfect navigation, and perfect release timing. But military planners recognized that the fundamental concept remained sound. The problem wasn't gliders themselves, but inexperienced pilots, inadequate training, and poor planning. German glider operations had succeeded because German pilots were superbly trained and their missions meticulously planned. American and British forces would need to match that proficiency. Training intensified dramatically. By early 1944, glider pilot schools at bases across the United States were operating nearly around the clock. Pilots learned to land in impossibly short fields, to judge distances at night, to handle turbulence and crosswinds. They practiced emergency procedures for every conceivable failure: tow rope breaks, structural damage, one-wheel landings. The glider itself received modifications based on combat experience. Reinforcements strengthened areas that had failed in Sicily. New procedures established more conservative release distances. Tow pilots received specialized night formation training. Pathfinder teams would now mark landing zones with lights and radio beacons. By June 1944, the U.S. had produced over 10,000 CG-4A gliders. Ford's Kingsford plant alone was producing 8 gliders per day at an average cost of $15,400 each, dramatically cheaper than the $25,000 plus other manufacturers charged. The entire production network of furniture makers, piano manufacturers, and refrigerator companies had become remarkably efficient. But questions lingered. Glider pilots called their aircraft flying coffins, tow targets, and death crates. The fabric and wood construction provided no armor, no protection. A single machine gun burst could shred canvas and splinter wooden wing spars. Landing on rough terrain meant certain structural damage. Most gliders sustained damage severe enough to make them unflyable after a single mission. Unlike powered aircraft pilots who could fly multiple missions, glider pilots had one chance to get it right. No engines meant no go-around, no second approach if the first landing attempt failed. Once the tow rope released, physics took over. The glider would descend at approximately 300 feet per minute, find a field, judge the approach, avoid obstacles, land without cracking up, all while under fire, at night, in a combat zone. Training casualties reflected this reality. Between 1942 and 1945, nearly as many American glider pilots died in training accidents as would die in combat. Wings separated in flight due to faulty construction. Tow ropes snapped, gliders stalled on final approach and crashed, yet production continued accelerating. By D-Day, over 13,000 CG-4A gliders had been delivered. The largest airborne operation in history was about to test whether Sicily's lessons had been learned, or whether gliders would prove to be an expensive mistake. June 6, 1944, 0119 hours. Airfields across southern England. The first C-47 Sky trains towing gliders for Operation Chicago lift off into the pre-dawn darkness. 52 Waco CG-4A gliders carrying 155 men, a bulldozer, 16 anti-tank guns, and 11 tons of equipment are bound for Landing Zone E near Heysville, Normandy. Simultaneously, Operation Detroit launches 52 more gliders toward a different zone for the 82nd Airborne Division. This time, planning is meticulous. Unlike Sicily's rushed preparation, D-Day glider pilots have trained for months. Pathfinders dropped hours earlier have marked landing zones with radio beacons and lights. Release points are calculated to give gliders maximum margin for error. The meteorological forecast, though not perfect, is accurate. At 0354 hours, the first gliders release over Normandy. Unlike the scattered disaster of Sicily, the results show dramatic improvement. 6 gliders land directly on Landing Zone E. 15 more land within 750 meters. 10 gliders come down in a field near Les Forges. The remainder land within a 3-kilometer radius, scattered but not catastrophically so. But Landing Zone E presents problems the planners never anticipated. Normandy's bocage country, small fields enclosed by earthen banks topped with thick hedgerows, creates a deadly obstacle course. Hedgerows that looked like minor features on aerial photographs turn out to be 15-foot-tall barriers with trees growing from their tops. Fields that appeared spacious from altitude measure only 300 to 400 feet across, half the normal landing distance required by a fully loaded CG-4A. Staff Sergeant Charles Skidmore's glider slams into a hedgerow at 60 miles per hour. The canvas skin tears away, the wooden wing structure splinters. The Jeep inside breaks free and crushes forward. Skidmore survives with a broken collarbone. 3 of his passengers don't survive at all. Glider after glider meets similar fates. Some touch down smoothly only to have their landing gear collapse when they roll over uneven ground. Others overshoot small fields and plow into the opposite hedgerow. Still others collide with gliders that landed moments earlier, their pilots unable to see obstacles in the darkness. Lieutenant Colonel Murphy's glider carrying General Pratt represents the operation's most tragic loss. Despite Murphy being considered the finest glider pilot in U.S. airborne forces, the added armor weight makes the glider unmanageable on landing. When it hits the hedgerow, General Pratt becomes the first American general to die on D-Day. By dawn, the accounting begins. Operation Chicago, 5 dead, 17 wounded, 7 missing. Operation Detroit, landing near St. Mary-Glise, suffers worse. 10 dead among glider pilots alone, with dozens more wounded. The 101st Airborne Division lost 30 men in glider crashes. The 82nd Airborne lost 300. Yet crucially, the missions succeed tactically. Unlike paratroopers who landed scattered across Normandy, glider troops arrive in cohesive units. The 16 anti-tank guns delivered by Chicago gliders provide the 101st Airborne with heavy firepower that parachute drops could never have delivered intact. Jeeps and trailers give commanders mobility. Radio equipment enables communication with the invasion fleet offshore. Lieutenant General Omar Bradley later writes in his after-action report, "Gliders proved their worth on D-Day. Despite heavy casualties in landing, they delivered concentrated combat power exactly where needed." But the casualty figures force uncomfortable questions. Military planners had estimated 10 to 15% losses. Actual losses in some glider serials exceeded 20%. Compared to parachute drops, which scattered troops but rarely killed them outright, glider landings killed or seriously injured troops before they ever fired a shot. The construction method that made mass production possible also made the gliders extremely vulnerable. Enemy fire analysis after Normandy reveals the fundamental problem. The CG-4A has no protection whatsoever. Canvas skin tears under small arms fire. Wooden wing spars splinter when struck by shell fragments. The tubular steel frame crumples on impact with solid objects. August 1944. Aberdeen Proving Ground, Maryland. Army ordnance officers examine a CG-4A brought back from Normandy. The glider survived landing but took multiple hits from German machine gun fire during the subsequent ground battle. The examination reveals what pilots already knew instinctively. A Waco glider provides protection comparable to a canvas tent. A single 7.92 mm bullet from a German Mauser rifle penetrates both sides of the fuselage, passing through canvas, past passengers, through the opposite canvas wall. A burst from an MG-42 machine gun shreds a 3-foot section of wing covering and severs 2 wooden wing ribs. Small shell fragments from a mortar strike riddle the tail section with holes. Compare this to a C-47 transport aircraft built from aluminum with self-sealing fuel tanks and armor plating around the cockpit and crew positions. A C-47 can absorb significant battle damage and continue flying. A glider's battle damage ends only one way, on the ground, often with the pilots and passengers trapped inside a burning wreck. Engineers examine alternatives. Could gliders be armored? Quick calculations show the problem. Armor plate sufficient to stop rifle bullets weighs approximately 40 pounds per square foot. Armoring even the cockpit would add 800 to 1,000 pounds, reducing cargo capacity by nearly a third and dramatically increasing landing speed. Full armor protection would make the glider too heavy to tow. Could gliders use aluminum instead of wood and canvas? Again, the numbers don't work. Aluminum gliders would require aircraft-quality materials and aircraft manufacturing facilities, precisely the resources that weren't available. The entire point of the glider program was to produce aircraft using non-aerospace industrial capacity. The cold mathematics are brutally clear. The CG-4A is exactly what its pilots call it, a flying coffin, not because of poor design, but because of deliberate design choices. Every pound of protection is a pound of cargo capacity lost. Every design feature that increases survivability adds complexity and manufacturing cost. The glider exists at the intersection of two competing requirements: deliver heavy equipment behind enemy lines and do it only using materials and manufacturing capacity outside the aviation industry. These requirements inevitably produce an aircraft where crew survival is secondary to mission accomplishment. September 17, 1944, Operation Market Garden, the Netherlands. Despite Normandy's lessons, larger glider operations continue. The CG-4A, for all its limitations, remains the only way to deliver intact combat units with heavy equipment behind enemy lines in the pre-helicopter age. Nearly 500 American gliders participate in Market Garden, attempting to land troops near bridges at Nijmegen and other strategic points. War correspondent Walter Cronkite, riding in a glider, describes the scene. Gliders were landing around us, but others came tumbling out of the sky. Two collided almost above us, and a jeep, a howitzer, and soldiers came crashing down. A C-47 came low overhead, streaming smoke, and exploded in the woods just beyond. Another glider came straight down and plowed into the soft earth like an artillery shell. The pattern repeats: tactical success, heavy casualties. The gliders deliver their cargo. The men inside pay the price. The death of General Pratt and hundreds of glider troops forces a fundamental question. Why did America build aircraft this way? The answer lies in decisions made in early 1942 when U.S. military planners faced competing requirements that couldn't all be satisfied simultaneously. Requirement 1: rapid mass production. By June 1942, when the first CG-4A rolled out of the Waco factory, the U.S. had been at war for 6 months. Military planners projected needing at least 10,000 gliders for the eventual invasion of Europe. Traditional aircraft production, even if capacity existed, required 18 to 24 months to tool up and reach full production rates. The glider program needed aircraft in 12 months. This dictated every subsequent design decision. The CG-4A had to use materials and manufacturing techniques available immediately from non-aerospace companies. No exotic aluminum alloys requiring specialized rolling mills. No complex aircraft quality riveting requiring trained aerospace workers. Just wood, canvas, and steel tubing, materials that furniture makers, piano manufacturers, and refrigerator companies already knew how to work with. Requirement 2: minimal strategic resources. Every pound of aluminum used for gliders was a pound not available for bombers, fighters, and transport aircraft. In 1942, aluminum production was a strategic bottleneck. B-17 Flying Fortresses required 15,000 pounds of aluminum each. B-24 Liberators needed 18,000 pounds. C-47 transports consumed 8,000 pounds. The entire U.S. aluminum industry in 1942 was producing approximately 1.5 billion pounds annually. Every glider built from aluminum would consume resources equivalent to a fighter aircraft. Waco's design used less than 200 pounds of aluminum components, mainly for control cables, instruments, and a few critical fittings. The rest was wood, canvas, and steel tubing that used no strategic materials whatsoever. Requirement 3: low unit cost. The brutal economic reality: gliders were expected to be expendable. Unlike bombers that flew hundreds of missions, a glider made one flight into enemy territory. Recovery, while theoretically possible, was impractical. Most gliders would be destroyed in landing or abandoned after delivering their cargo. This meant unit cost had to be minimal. Ford's Kingsford plant ultimately achieved $15,400 per glider, roughly one-third the cost of a single Jeep. Even at market rates averaging $25,000 per glider, the economics worked. 13 gliders cost less than one B-17 bomber. Aluminum construction would have tripled the cost. Armoring would have quintupled it. The impossible choice. These three requirements created an impossible trilemma. The mathematics were brutally simple. To achieve rapid mass production, use non-aerospace manufacturing, sacrifice sophisticated construction, accept structural vulnerability. To minimize strategic resources, eliminate aluminum, use wood and canvas, accept vulnerability to battle damage. To achieve low unit cost, design for single use, eliminate protection, accept high crew casualty rates. Military planners understood these trade-offs from the beginning. Gliders would have high casualty rates, but they also understood the alternative. Without gliders, airborne operations would be limited to what paratroopers could jump with: small arms and light equipment. Heavy weapons, vehicles, ammunition in quantity all required gliders. The decision came down to cold calculation. Were glider casualties acceptable if they enabled airborne operations to succeed? Could you justify losing 20 to 30% of glider troops in landing if the remaining 70 to 80% arrived with the combat power to hold their objectives? The planners decided yes. Designer's perspective. Francis Arcier, the CG-4A's designer, later defended his creation in testimony before a 1945 Army Review Board. The glider was designed to meet specifications provided by the Army Air Forces. Those specifications prioritized payload capacity, ease of manufacture, and low cost. Crew protection was not among the primary requirements. I designed the best aircraft possible within those constraints. The CG-4A accomplished exactly what it was designed to accomplish: delivery of combat troops and equipment using non-aerospace manufacturing capacity. That it could not also provide crew protection was an outcome of the specifications, not a failure of design. Arcier was correct. The CG-4A was not poorly designed. It was brilliantly designed to achieve specific goals. Those goals simply didn't include bringing American crews home safely. Compare this to German glider philosophy. The DFS-230, Germany's primary glider, carried only 9 troops versus the CG-4A's 13. It used more sophisticated construction techniques and higher quality materials. German military doctrine accepted higher unit costs in exchange for better crew survivability. The difference reflected broader philosophical divides. German military planning emphasized quality over quantity, accepting lower production numbers for superior equipment. American planning emphasized quantity over quality, accepting higher casualty rates for numerical superiority. By 1945, Germany had produced approximately 1,500 DFS-230 gliders. America had produced 13,903 CG-4As, more than 9 times as many. In the aggregate, American glider operations delivered more combat power to more objectives despite higher per-mission casualty rates. The hidden cost. What the planners couldn't quantify was psychological cost. Glider pilots understood they were flying what amounted to controlled crashes into enemy territory with no second chances. They flew without parachutes. There was no altitude for bailout. They flew without armor. There was no protection from enemy fire. Unlike bomber crews who could attempt evasive maneuvers, fighters who could dogfight their way out, or paratroopers who could steer their chutes away from threats, glider pilots had only physics. Once the tow rope released, they were committed to landing wherever the glider's glide ratio took them. One pilot described it simply: 17 seconds from release to impact, 17 seconds to find a field, judge the approach, and get down without killing everyone aboard. Every single time. The question wasn't whether pilots and troops would die in gliders. The question was how many would die achieving objectives that couldn't be achieved any other way. By March 1945, that question would have its final answer. March 24, 1945, Operation Varsity. The Rhine River crossing. The largest single-day airborne operation in history unfolds at 10 hours. More than 900 American CG-4A gliders and 440 British Horsa and Hamilcar gliders converge on landing zones east of the Rhine. Their mission? Deliver 2 complete airborne divisions, the U.S. 17th and British 6th, behind German defensive positions to secure bridgeheads for advancing ground forces. Unlike Normandy's night landings, Varsity launches in broad daylight. Allied air superiority theoretically protects the gliders from Luftwaffe fighters, but daylight also means German anti-aircraft batteries have perfect visibility for the slow-moving, vulnerable gliders crossing at 150 miles per hour. The slaughter begins at 10:17 hours. German 88mm flak batteries open fire as the first gliders release from their tow planes. The 88mm shell, designed to destroy bombers at high altitude, is devastating against canvas and wood gliders at low altitude. A single shell can obliterate a glider entirely. Staff Sergeant Frank Norris, piloting a glider carrying troops of the 194th Glider Infantry, watches an 88mm shell pass directly through the glider ahead of him. The shell enters through the canvas fuselage, detonates inside, and exits through the roof. The glider's nose drops instantly, the entire control surface destroyed. It falls like a stone, trailing debris and bodies. German machine gun positions rake landing zones with interlocking fire. MG-42s firing at 1,200 rounds per minute shred canvas coverings. Tracers ignite the cellulose acetate dope coating the fabric. Gliders land, taxi to a stop, and burst into flames within seconds. In LZW, 18 gliders land successfully, only to be caught by a German 105mm howitzer battery that has direct line of sight to the zone. The battery methodically shells the stationary gliders. Some crews manage to evacuate before their gliders explode, others don't. Technical Sergeant Howard Melvin's glider takes multiple machine gun hits during final approach. The canvas tears away from the wing's leading edge, changing the airfoil's shape and destroying lift on the left side. The glider snap rolls left and impacts inverted. Melvin and his co-pilot survive with severe injuries. All 13 soldiers in the cargo bay die on impact. By noon, when the last gliders land, the accounting reveals Operation Varsity's cost: 88 American glider pilots killed, 240 wounded. Varsity represents the culmination of a pattern established across 3 years of glider operations. Sicily, July 1943, 144 gliders launched, 58 reached land, 12 landed near objectives, 250 troops drowned, 14 British glider pilots killed, 87 missing or wounded. Normandy, June 1944, 517 American gliders participated in Neptune operations, delivering 3,937 troops. D-Day glider casualties, approximately 400 killed and wounded in landing accidents before combat even began. Market Garden, September 1944, 478 American gliders delivered troops near Nijmegen. Heavy losses to German anti-aircraft fire and collisions. Precise casualty figures vary by source but exceed 100 killed in landing accidents before combat began. Burma, March 1944. 68 gliders launched in Operation Thursday. 31 reached landing zone Broadway. 11 pilots killed, 18 wounded. Multiple gliders broke free from overloaded tow planes and crashed. Southern France, August 1944. 407 gliders participated in Operation Dragoon, 23 pilots killed, 63 wounded, relatively successful compared to other operations. Battle of the Bulge, December 1944, 61 gliders delivered critical resupply to 101st Airborne at Bastogne, 4 pilots killed, 18 wounded. These suicide missions received virtually no press coverage despite flying directly into active combat zones. The cumulative statistics paint a clear picture. Between 1943 and 1945, American glider operations saw casualty rates for pilots and troops that consistently ranged from 10 to 25% in the landing phase alone, before enemy ground combat casualties were counted. Compare this to powered aircraft losses. B-17 bomber groups flying over Germany in 1944 suffered approximately 3 to 4% loss rates per mission. Fighters had even lower loss rates. Yet glider pilots faced 10x higher casualties in a single flight that couldn't be repeated, couldn't be aborted, and offered no possibility of evasion or return to base. Survival accounts. First Lieutenant Robert Callahan, who flew gliders in both Normandy and Holland, later described what made glider operations psychologically devastating. With a powered plane, you have options. Engine trouble, you can try to make it back. Heavy flak, you can take evasive action. With gliders, once that rope drops, you're committed. You're going down into that field whether you want to or not, whether it's safe or not, whether the enemy is waiting or not. Every landing is a controlled crash. You just try to make it controlled enough that people survive. Technical Sergeant Morris Fuller, shot down twice in different gliders, explained the cruel mathematics. 13 guys depending on me to get them down alive. 79,000 pounds of wood, canvas, and cargo. No engine, no second chance. You either find a field or you don't. You either avoid the obstacles or you don't. You either walk away or you don't. Of the approximately 6,000 American glider pilots trained between 1942 and 1945, nearly 10% became casualties, comparable to combat infantrymen's casualty rates. The gliders themselves fared worse. Of the 13,903 CG-4As produced, approximately 98% were destroyed or damaged beyond repair in their single operational mission. Less than 200 survived the war intact. By VE Day, May 8, 1945, the full accounting of America's glider program could be calculated. Production statistics. Total CG-4A gliders manufactured, 13,903 units. Some sources cite 13,909. 16 primary contractors. Ford Motor Company, Kingsford, Michigan, 4,190 units at $15,400 each. Northwestern Aeronautical Corporation, St. Paul, 1,509 units. Commonwealth Aircraft, Kansas City, 1,470 units. General Aircraft Corporation, Queens, New York, 1,112 units. Gibson Refrigerator Company, Greenville, Michigan, 1,078 units. Cessna Aircraft Company, Wichita, Kansas, 750 units, subcontracted to Boeing, Wichita. G&A Aircraft, Willow Grove, Pennsylvania, 627 units. 14 other manufacturers, approximately 4,167 units combined. Hundreds of subcontractors provided components. Steinway Sons, wings and tail surfaces using piano construction techniques. H.J. Heinz Company, wings and spar tips. Anheuser-Busch, inboard wing panels and wooden fuselage frames. Gardner Metal Products, coffin maker, steel fittings. American Lady Corset Company, silk drogue parachutes. Technical specifications: wingspan 83 feet 8 inches, length 48 feet 4 inches, height 15 feet 4 inches, empty weight 3,700 pounds, maximum gross weight 7,500 pounds, emergency maximum 9,000 pounds. Cargo capacity 3,750 pounds normal, or 13 troops, or 1 jeep, or 1 75mm howitzer. Construction: tubular steel frame, wooden wings, cotton canvas covering. Tow speed 125 miles per hour. Glide speed 72 miles per hour. Landing speed 60 miles per hour. Stall speed 49 miles per hour. Glide ratio approximately 15:1. Total component parts 70,000 individual pieces. Honeycomb floor 5,000 interlocked wooden pieces. Combat deployment: major operations utilizing CG-4A gliders. Operation Ladbroke, Sicily, July 1943. Operation Thursday, Burma, March 1944. Operation Neptune, Normandy, June 1944. Operation Dragoon, Southern France, August 1944. Operation Market Garden, Holland, September 1944. Battle of the Bulge resupply, December 1944. Operation Varsity, Rhine, March 1945. Human cost: approximately 6,000 glider pilots trained by U.S. Army Air Forces 1942 to 1945. Combat and training casualties combined, approximately 600 killed, several hundred more seriously wounded. Casualty rate, roughly 10%, comparable to infantry casualty rates. Comparative analysis: the CG-4EA versus comparable aircraft. British Horsa glider. Capacity: 28 troops versus the CG-4EA's 13. Construction: wood and canvas, similar to the CG-4EA. Landing speed: 70 miles per hour, faster, more dangerous. Damage rate: nearly 100% of horses damaged in combat landing. Production: 3,799 units. German DFS-230. Capacity: 9 troops versus the CG-4EA's 13. Construction: metal tube and fabric, higher quality. Combat debut May 1940 under Eben Emael. Production: 1,500 units. Philosophy: quality over quantity, better crew protection. The economic calculation: average CG-4EA cost $15,400 to $25,000 depending on manufacturer. For comparison, B-17 Flying Fortress bomber $238,329, C-47 Skytrain transport $88,574, P-51 Mustang fighter $50,985, M4 Sherman tank $44,556, Jeep $738, One B-17 bomber cost as much as 15 CG-4EA gliders. The economic logic was inescapable. Gliders provided the most cost-effective method of delivering heavy equipment behind enemy lines. Post-war fate. Within months of VE Day, the glider program ended. Helicopters, which could land troops without crashing, extract them afterward, and be reused indefinitely, made gliders obsolete. By 1946, virtually all surviving CG-4EAs were sold as surplus for $25 to $50 each. Most were burned for their wood or scrapped for materials. Today, fewer than a dozen restored CG-4EA gliders exist worldwide. The National Museum of the U.S. Air Force and the Air Mobility Command Museum house two of the finest examples. June 7, 1944, Landing Zone E, Normandy. American infantrymen from the 4th Infantry Division, having pushed inland from Utah Beach, reached the fields where the gliders landed the previous morning. The scene resembles an aircraft graveyard. Wrecked gliders lean at awkward angles against hedgerows. Some are burned to skeletal frames, just charred steel tubing and ash. Others sit apparently intact until closer inspection reveals shattered wooden wing spars, torn canvas, collapsed landing gear. One glider has its nose embedded in a stone wall. Another lies inverted, its tail pointing skyward. A third sits perfectly upright in a small field, looking almost ready to fly again, until you notice the 20mm cannon holes stitching its fuselage. Medics move among the wreckage, checking for wounded still trapped inside. Most of the glider troops have already moved to their combat assignments. The pilots, following doctrine, are being evacuated back to England, those who survived. Captain James Howard walks past the wreckage of Fighting Falcon, the glider that carried General Pratt. The jeep is still visible through the collapsed nose section, crushed against what used to be the cockpit. Recovery teams have already removed the bodies. Howard, a veteran transport pilot, tries to imagine what it took to deliberately pilot an engineless wooden aircraft into enemy territory at night, knowing survival depended entirely on finding a suitable field in the darkness, avoiding obstacles you couldn't see, and walking away from a landing that, by definition, was a controlled crash. He cannot imagine it. Yet 517 pilots had done exactly that yesterday morning over Normandy. More would do it again tonight in follow-up missions. The story of the CG-4A glider forces an uncomfortable truth about warfare. Sometimes the least sophisticated solution is the necessary solution. The Waco glider wasn't elegant, it wasn't safe, it wasn't reusable, but it accomplished what nothing else could, delivering complete combat units with their equipment exactly where needed, using only the industrial capacity available outside the aerospace industry. The piano makers, furniture builders, and refrigerator manufacturers who built these aircraft created a weapon that was, paradoxically, both crude and sophisticated. Crude in construction, wood and canvas rather than aluminum, sophisticated in concept, a disposable aircraft that mobilized an entire nation's non-aerospace industrial base for the war effort. The glider pilots who flew them understood this better than anyone. They called their aircraft flying coffins, not as criticism, but as simple statement of fact. The gliders were designed to deliver cargo, and that cargo happened to include the pilots themselves. Their survival was desirable, but not required for mission success. In that brutal calculation lies the complete story of the CG-4A. It was not poorly designed, it was brilliantly designed to achieve specific goals within specific constraints. Those goals prioritized mission accomplishment over crew survival, quantity over quality, speed of production over sophistication of construction. And because of those choices made deliberately in 1942 by military planners facing impossible alternatives, complete airborne divisions landed in Sicily, Normandy, Holland, and across the Rhine with jeeps, artillery, and supplies that paratroopers could never have jumped with. The cost was 13,903 disposable wooden aircraft and hundreds of pilots and soldiers who died in landing accidents before firing a shot in combat. The CG-4A succeeded precisely because it accepted that cost as necessary. In the pre-helicopter age, there was no other way to put an army behind enemy lines silently with the heavy equipment needed to hold ground once taken. The gliders scattered across Landing Zone E tell that story in wooden spars and torn canvas, a story of accepting casualties to achieve objectives that couldn't be achieved any other way. May 8, 1945, the war in Europe ends. Within weeks, the glider program ends with it. Helicopters emerge as the technology that will replace gliders, aircraft that can land troops, extract them afterward, and be reused indefinitely. But for 24 months between June 1944 and the war's end, the CG-4A glider was the only way to deliver heavy combat power behind enemy lines. And it worked, not because it protected its crews, but because it didn't need to in order to accomplish its mission. That remains its legacy. Proof that low-technology solutions, built by industries with no aerospace experience, can be just as decisive as advanced weaponry, if military planners are willing to accept the human cost of disposability. The last operational CG-4A flight occurred in the early 1950s when the Air Force used gliders for Arctic research operations, landing scientists on ice floes. By then, the combat gliders were museum pieces and memories. Today, when military operations deploy troops by helicopter, aircraft that cost millions, require extensive maintenance, and can be used hundreds of times, it's worth remembering the alternative, a $15,000 aircraft made by piano makers, designed for a single one-way flight, accepted as expendable because it was the only way to win a war when the nation's aerospace industry couldn't build what was needed. The CG-4A glider wasn't an engineering triumph. It was an industrial mobilization triumph, proof that America could win not just with advanced technology, but with clever use of the full breadth of its industrial capacity, even when that meant asking furniture makers to build aircraft and pilots to fly them knowing they might not walk away.